Okay, let's talk about geometric sequences today. So, geometric sequences. My handwriting is extra bad. I don't know why. Okay, so geometric sequences. These have no common difference. But there is a common ratio. Our explicit formula is always a sub n equals a1 times r to the power of n minus 1. A sub n is just our nth term, so a sub 5 would be our fifth term, a sub 6 would be our sixth term, etc. A sub 1 then is our first term, and r is our common ratio. For our recursive formula, we have a sub n equals a sub n minus 1 times our r. So the nth term is equal to the prior term, a sub n minus 1 times r, which is our common ratio. So we will do some examples. So first example, let's look at 3, 9, 27, 81. So if you can look at this and see, okay, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, great. If not, to find your r, or your common ratio, you can just take, the second term minus or divided by the first term, so 9 divided by 3. Or you can do the third term divided by the second term, 27 divided by 9. Or you could do 81 divided by 27. Either way, this will equal 3. Let's put our term numbers up here too, just because. Okay, so our explicit formula, a sub n, so any given term, our first term, which is 3, times our common ratio, which is 3 to the n minus 1. That's one way you could write it. I probably tend to write it with parentheses like this, 3 times 3 in parentheses n minus 1. They're both right. I just tend to favor parentheses because I think it makes things extra clear. So for example, to find your fourth term, you could look at a sub 4, which would be 3 times 3 to the 4 minus 1, which is 3 times 3 cubed, which is 3 times 27, which is 81. So our fourth term should be 81, and it is. Awesome. So our formula most likely is good. Okay. Recursively, it's all about what's happening to get to the next term. So a sub n equals a sub n minus 1 times, well, every term is being multiplied by 3. So if we want to check this, we can look at and say, well, the second term equals the first term times 3. Yep. Third term equals the second term times 3. Yep. So we should be good. Next example. Draw a little picture. Let's say we have 2 circles. Now we have 4 circles. Now we have 1, 2, 3, 4, 6, 7, 8 circles. Okay? Pretend those are all equal size. So it looks like our first term is 2, second is 4, third is 8. So you may see this and just say, well, yeah, it's being multiplied by 2. 2 times 2 is 4. 4 times 2 is 8. Or you could say 4 divided by 2, which is 2. 8 divided by 4, which is 2. Either way, our R, or our common ratio, is 2. So then for our explicit formula, let's put our term numbers. So first term, second term, third term. So for our explicit formula, a sub n equals, well, our first term is 2, then our r is 2 to the n minus 1. And so to check, let's look at the third one. So a sub 3, which is our third term, should be 2 times 2 to the 3 minus 1, or 2 times 2 squared, or 2 times 4, which is 8, and it should be 8, so we're all set. Recursively, it's just about how do you get from one term to the next. And a sub n equals a sub n minus 1 each time we're multiplying by 2. So the second term equals the first term times 2. The third term equals the second term times 2. Let's do one last example. Let's look at 16, 4, 1, 1/4. This one's slightly trickier maybe to see what's being multiplied. So let's do it this way. R would be 4 divided by 16, or 1 divided by 4, or 1/4 divided by 1. All of these simplify to be 1/4, meaning to get from 16 to 4, you'll multiply by 1/4. To get from 4 to 1, you multiply by 1/4. To get from 1 to 1/4, you multiply by 1/4. Again, you don't have to do this step here with the division, but if you get stuck, that's how to figure it out. So then our explicit formula, a sub n equals, well, our first term is 16, times our r, which is 1/4 to the n minus 1. For example, let's look at our third term. So a sub 3 should be 16 times 1/4 to the 3 minus 1, or 16 times 1/4 squared. Well, 1/4 squared is just 1 squared, which is 1, over 4 squared, which is 16. And 16 times 1/16 is just 1, and that's our third term, so we're good. Our recursive formula, a sub n equals a sub n minus 1. If you look up here to get from first term to second, second term to third, third term to fourth, time to just assume the term numbers, we can write them up there too, if that helps you do the problems. And each time we're multiplying by 1/4. So a sub n equals a sub n minus 1 times 1/4. Technically, multiplying by 1/4 is the same as dividing by 4. So if you want, you could say a sub n equals a sub n minus 1 divided by 4. That is also an appropriate recursive formula that fits this sequence.